So with an SPC floor system, the beauty of it is, like Matthew basically touched on, if your substrate is not structurally sound to withstand putting a self-leveling screed over it, excuse me, or furthermore to put down a LVT plank, you've got a system that will favor it. With the SPC, it is floating, so it's not structurally bound to the cement or the topping or to the screed. It will float independently. On top of that, as you can see over there, we can lay this over most floor surfaces so long as it's structurally sound. Right? Tiles through to concrete floors, screeded floors, timber floors as well, but I would be hesitant against suspended floors, as there could be a bit more give than what there would be with, for instance, plywood that you would structurally make sure that it's sound. Every 300, 400, put in a screw and make sure that it's sound. Otherwise, if there is any deflection, it will be putting strain on your clipping system, and it will shear, it will splinter, and your floors will separate.
If I can just add there, Jesse, I'm going to step in on this one. It's just like with SPC, it is super strong on the horizontal plane. So with regards to pushing and pulling and doing what it's designed to do, it's got the good stuff, all right? But we need to understand that like the vertical plane, we need to be very careful, because now we're looking at a joint system that's maybe a mil or so, holding 1.5 mils, holding the planks together. It's weak, all right? So this is a super fantastic system, horizontal strength, but vertical movement over a timber substructure where there's bounce. You want to make sure that when you're walking across the floor that there is no vertical movement. That is kept to an absolute minimum, because that's where the product is going to show its weakness. Sorry, Jesse, I had to do that.
No worries. Thank you very much. So in terms of this floor, it can be pushed depending on what product you're going to be taking. If you're going to go for the commercial setting, the diamond core, or if you're going for the residential setting, which is the sapphire, up to 250 squares easy. Going more commercial now. If you're going for residential, you're looking at about 150 to 200 squares comfortably. That is in an uncontrolled environment. What do I mean by uncontrolled environment? That is something that is not climatically controlled like overseas, where you've got double glazing, triple glazing windows. You've got a thermostat running 24/7, keeping it at a constant 21, 27 degrees Celsius. If you do have that kind of environment, you could probably run this by a kilometer comfortably, because there's no external movement or indication that it's going to be moving, because the temperature's not changing.
Nice and stable.
That's it.
Absolutely. All right, and then with regards to clicking that product together, like we're familiar with a laminate floor, it's a click system. So the installation, really, it's not rocket science, but again, like I said earlier, with that vertical movement, this is the one time where that plank, individual planks are going to be played around in a vertical situation, and that's where the installer just needs to respect that joint system. You know, it needs to go in the correct methodology of that brand. Different brands have different clicking mechanisms. One mechanism or one format is not for all the planks, and this is where potentially, things could go wrong.
Definitely. I've seen many a site where I've gone in for an inspection afterwards where a little bit incompetent installers go and overwork the joints, like Barry says. That's where you get what we call a hot wire effect. It works that joint vertically up and down, and eventually it just shears off, breaks off, and you've got planks separating.
Or there's also the good old ski ramp. All right, the ski ramp where we are clicking in the short end at a 45, and we are lifting up the plank that's already been installed, the adjacent plank, to get the long clicking mechanism together, and we've kind of like applied too much pressure. And then that will present itself across the floor, and you can't make it go away. You start again, all right? And it gets expensive. So definitely the installer, as always, Flooring Africa, we love supporting top installers, because they safeguard these products.
That's critical.
Right, okay. I think I'm ready. Glue down LVT, LVP, it requires skill and understanding in how this product responds to its environment. First of all, just by the product, when we're talking about polyvinyl chloride and calcium carbonate and those ingredients that make up this product, it's thermoresponsive. So as I heat it up, it will grow in dimension. If I cool it down, it will shrink. So we've got to control our environment, because otherwise that expanding contraction is going to cause havoc in our end results. Okay, so we did a YouTube video some time ago, around about 3 years ago, and we took some planks from 4 different suppliers, put them in my lounge in the shadow. All right, just loosely. We left them there for a couple of hours so that they were acclimatized. And then as the sun is bearing through my sliding door window, where we have the sun hitting the floor, we then went and pushed the planks into the sun for 10 minutes. All right. Across the board, we had plank growth in length by between 1.5 and 2 millimeters per plank. So you can just imagine that's 10 minutes. All right. You can just imagine what that's going to do when it's exposed for hours on end, day in, day out, or even as the installer is busy laying the planks from the back of the room, which is in shadow. Now he's coming up to the sliding door and he's in that hot spot for that day. And those planks are starting to grow as he's pushing them into Matthew's wet adhesive. All right? Now it comes to evening. The sun has shifted. Those planks are cooling down. Now they're contracting. Have any of you ever experienced where you've seen luxury vinyl tile planks installed where the headers have opened up? So meaning that there's little gaps on the short end of the planks. Okay? So this is where the site control becomes absolutely mission critical. So if you've got sun hitting the floor where you're going to be installing LVT, you've got to brown paper up those windows. You've got to control that job site. Okay, windows, sliding doors that are open, where there's a cross ventilation, whatever. You've got to try and stabilize that site as much as possible. A good installer will do that for you to prevent the working of that glue. As you're installing those planks, if that glue bond is already under pressure and those planks are moving while you're trying to dry that, allow the glue to dry, cure, you can imagine how that glue bond is being compromised. Now, Matthew, your glue takes, 8 hours to full cure?
Yeah.
Approximately.
Yeah,
different glues, they take different cycle of hours. You know, the planks are generally, they'll be between 6 to 8 hours, and you want to leave them for 24 hours for a full cure. But you can just imagine those planks trying to move during that period. And the more they move, the more you're compromising that bond. So as it goes through heat cycles in days, months, and years later on how things just start deteriorating very quickly. Okay, so a good installer is going to bring that skill to the job.
Sorry, Barry, if I can step in there as well on a point that you've touched lightly. So with that belting sun coming in, or with the doors open, the ventilation coming through, another key component of an LVT with the adhesive side is your flash off time. So basically your flash off time is where the glue is busy curing. And you've only got a small window of actually applying the LVT or LVP directly to that adhesive before it creates a skin. And as soon as it creates that skin, you've got no grip, no bite onto the subfloor, which means that your panel's just going to lift. And you've got bigger issues down the line. Now I'm sure with Tile's product you can do a loose lay, but generally there is a little bit of a window, especially on your first few lines, where you want to give it about 10 minutes, roughly, while you're doing your gauge out. Where you lay your first 2 to 3 lines square off before you carry on.
So you want something steady to push up against, because imagine you're putting it into a wet adhesive. Now everything's just sliding around. So there's a methodology. Now different glues have different techniques. Some guys even use contact adhesive. All right, you can just imagine all the VOCs and the chemicals expelling into the environment and into those homes under those kind of conditions. But they do that because it's got an instant grab. It locks that plank in place. You know, there's no negotiation. But what's the experience thereafter? So your system that supports the installation of your LVT is critically important. Okay, on how they talk to one another. With LVT, as we mentioned, it's thermoresponsive. So it responds in heat, it's going to grow in dimension, but it also relaxes. So you can imagine that I'm going to put this plank, which is fairly flat, and I'm going to put it over a, let's call it a 50-cent little coin divot in the screed, okay? If I allow that plank to go through a couple of heat cycles, I'll actually see that 50-cent recess telegraphing, or there's a technical word where it actually displays directly through the surface. So any little lump and bump that is in that substrate is going to shine through. And that's why we go through the process, and you would potentially already know this, that every time you install an LVT, you have to do self-leveling screed. But now you have one bid versus another. Somebody's going to say, listen, hands down, it's a 4mm screed. That's what we do. That's industry standard. But now somebody else is bidding, and they say, okay, fine, well, I'm only going to pull a 2mm screed. Okay? Now you can imagine, we're going to get into the costings on a slide later on, but you can see how the installer manipulation of all of these supporting products can make a massive impact into the bill at the end of the day. But it can also make a massive impact into your experience of this floor. Moisture. Oh, lovely. So as Matthew was saying, when we go and we take a layer of plastic or impervious layer, we put it over a cementitious substrate, we're going to be checking to make sure that there's no moisture in that slab. Now generally non-invasive moisture meters, they're going to put them on the surface, they're going to measure roughly 25 mil. As Matthew was saying, the slab is 100 to 150. As soon as we go and we measure, we say, hey, the moisture is where it should be. Let's call it 3%. All right, with my non-invasive moisture meter. I go and I cover it up. As soon as I cover up that cementitious slab, the moisture from below, if there is any, will now start rising up, equalizing across the volume. And then all of a sudden, what was a safe moisture measurement of 3% is now pushing up to 5.5%, 6%, and all of a sudden all hell is breaking loose. And I've got a failed LVT floor. Okay? LVT is failing where the installers do not understand the science and they are not measuring accordingly. So it is like, and the way that displays is, and Jesse, you can step in here with regards to where the planks are starting to vent. The short ends will start lifting, they'll be pushing up. And that's where the vapor is trying to expel. So when we start looking at glue down LVT, LVP, we've got to make sure that we are managing and we fully understand the condition of that substrate, the strength and the moisture. Mission critical, right? Climatically controlled installation. I think I covered that with regards to the thermal responsiveness. With regards to mirror, flat and smooth, I've done that. Moisture. Jesse, anything else I need to mention there? Am I good?
You've touched it quite well. I think the only thing that we can probably add to it is the rolling technique after the installation, but that comes down to the installer. Just making sure that you've got a good key in with the adhesive. The biggest issue that we see when we go revisit sites these days is adhesive starvation. Now, it can happen in many different ways. The installer has gone and he's done one good project, or he's done projects for the last 3 months, and that trowel, which is generally between a 1.6 to a 3mm notch trowel, V-notch trowel, has now grinded down from a 3mm, for argument's sake, all the way down to 1mm. And because you're pulling it at an angle, you basically have no transfer of adhesive onto the floor. Now with flash-off times and all that said and done, what's going to happen now is before you've got proper transfer from the adhesive onto the plank, well, there is no adhesive fundamentally, so the plank isn't properly keyed into the substrate, which means as you've got the temperature rising and the product wanting to move, it actually pulls itself loose, and then you've got problems down the line.
So what we see is that we don't get a full bond to the back of the tile, and it's for various reasons. Worn out trowels, adhesive that has already flashed off, it's already dry by the time somebody's been troweling on the adhesive and the guys are coming up behind and putting the planks down, but the adhesive might have already dried because it's a nice hot day, there's good airflow running across the adhesive, or that the floor was not rolled quickly enough while that glue was receptive. So we come across a failure that's displaying in various forms of lifting, peaking point, joints, etc. And we'll uplift the tile and we'll see that actually there's no glue transfer to the back of the tile.